And here, for doing this, we are having a sampling theorem. It specifies the minimum sampling rate at which a continuous time signal needs to be uniformly sampled so that the original signal can be completely recovered. This is very, very important. Completely recovered. There should not be any loss in our while doing our recovery process. So completely recovered or reconstructed by these samples alone. So the sampling rate is generally called as Nyquist rate. So here the condition is Fs is greater than and equal to 2 times Fm. So Fs is nothing but the sampling frequency. So how frequently we are taking our sample. So that frequency is the sampling frequency. And 2 into F into M. So sorry, F into F suffix. So F suffix M. So here this is the maximum frequency available, right? So if you are having more number of signals in a more number of frequency available in our signal, then out of that we have to calculate the maximum frequency. Then with reference to that, you have to calculate your sampling frequency. So the condition for sampling frequency, Fs is greater than and equal to 2 times Fm. So with this condition, we can able to recover our original signal. So if it is not satisfying, this condition is not satisfied, then we will have a aliasing problem. So this is due to the interference of the information between two band of frequencies. So if you are having the aliasing effect in our signal, then while doing our recovery process, we cannot able to get our original signal, or we cannot able to reconstruct our original signal without any loss. That is the meaning, right? So you have to follow this condition in order to recover our signal back completely without any loss.